Hello, my darlings. We are going to be starting the second part of Unit 2, which is looking at discrete probability distributions. So to do this, we need to talk about a random variable, and the random variable can be discrete or continuous, and we're going to talk about both, but we will mainly be focusing on the discrete. So a random variable is numerical, so that's a key, numerical. It's a numerical variable whose value depends on the outcome of a chance experiment. So we've already been doing that, talking about rolling a die, the probability of rolling a 4, things like that. So those are chance experiments. And discrete, we've already talked about the difference between discrete and continuous. So remember, discrete, a random variable is discrete if the set of possible values is a set of individual points on a number line, like shoe size, 5, 5.5, 6, 6.5, or the number of items in a shopping cart, or what number you roll when you roll a die. Continuous is if the set of possible values includes an interval on the number line. So like a height, a weight, a time, so usually a type of measurement. So example 1 says state whether each random variable is discrete or continuous. So the number of inches of hair cut off by the stylist, that would be continuous. That's a length, it's a measurement. Minutes between takeoff and landing of a flight, that is also continuous. It's a time interval. So it could have been 46 minutes, but it could have actually been 45.273 minutes. So it hits all the possibilities in between. The sum of 3 dice when rolled, well, that's discrete. It could be a sum of 3, a sum of 4, a sum of 5, but you can't get a sum of 4.79 or 12.156. Okay, so that would be discrete. All right, so here are random variables, and we're going to list all the possible outcomes. So for A, you pick 2 cards out of a regular 52 card deck. So our random variable is going to represent the number of face cards shown. So I could get maybe a 2 and a 10. That would have 0 face cards. I could get maybe a 2 and a jack. That would be 1 face card. Maybe I get a king and a queen. That would be 2 face cards. So those are the possible number of face cards I could hold when I draw 2 cards. You live 3.8 miles from school and you have to walk home. So why is the number of miles from home after 20 minutes? So maybe you're a fast walker and you just went straight home, didn't stop, didn't do anything else. So after 20 minutes, you're at home. So you're 0 miles away. Maybe for 20 minutes you decided to sit at school, talk to some friends, do some homework, you had a club meeting, anything like that. So you're still at school, which means you are still 3.8 miles from home. Or you could be on your way, which means you could be any number somewhere in between. So y is between 0 and 3.8. All right, so the probability distribution of a discrete random variable, this gives the probability associated with each individual x value. Okay, so in example 3, we're going to roll 3 dice, and x is the number of 4s that are showing. So we want to list all the possible outcomes, find those probabilities, create a probability distribution, and then use it to answer some questions. So possible outcomes, S I'm using for success, that's I see a 4. F I'm using for failure, I don't see a 4. So the worst possible outcome, failure, failure, failure. All 3 dice have any number except 4. Well, the probability of not getting a 4 is 5 out of 6. So the probability of failure, failure, failure is 5 out of 6 times 5 out of 6 times 5 out of 6. So having 0 4s has a probability of 125 out of 216. Or maybe 1 die shows a 4, but the other 2 do not. So that would be 5 out of 6 for failure, 5 out of 6 for failure, 1 out of 6 for success, but there's 3 ways it could happen. It could be the 3rd die was the success. It could be the 2nd die was the success. It could be the 1st die was the success. So I multiply that times 3 because there's 3 different ways it could happen. So the probability of getting 1 4 is 75 out of 216. The third way is I have 2 successes. So I have 1 failure and 2 successes. So failure, 5 out of 6. The probability of rolling a 4 is 1 out of 6 times 1 out of 6. But again, there's 3 different ways. I could have the first die be the failure. I could have the second die be the failure. I could have the third die be the failure. So I multiplied that by 3. So the probability of getting 2 4s is 15 out of 216. The last possibility is, yay, Funko, 3 4s, a 4, a 4, and a 4. So the probability of rolling 4, 1 out of 6, times 1 out of 6, times 1 out of 6. So the probability of rolling 3 4s is 1 out of 216. So pretty small probability. So now find the probability of getting at least 1 4. Well, that would be, I could have 1 4, 2 4s, or 3 4s. So all I have to do is add those 3 probabilities together, and I get 91 out of 216. Or find the probability of getting at most 1 4. That would be 0 4s or 1 4. So I just add those 2 probabilities together and get 200 out of 216. All right, so there's 2 properties for a distribution. So this is our distribution. That's what it looks like. Is each individual probability has to follow the basic probability rules. They can't be negative and they can't be bigger than 1. They have to be somewhere in between. And if this represents all the possible outcomes, when I add up those probabilities together, they have to add up to 1. So example 4, we're just going to determine if this could be a probability distribution. Well, X are the possible values. We could get a 15, a 20, a 25. Probability of getting a 15 is 0.4, but the probability of getting a 20 is negative 0.2. This cannot be a probability distribution. You cannot have negative probabilities. So B, X, so those are the possible X values, 7, 14, 21, or 28. These are the probabilities for each of those X values. They're all positive. They are all less than 1. And when I add them all together, they equal 1. So yes, this could represent a probability distribution. Hopefully that helps you out, and good luck on your homework.